Ladies and gentlemen, up next, we are going to have a discussion about data visualization. Please give a big round of applause for Andy Brist. And I do ask you to hold your questions until the end if anybody has any comments or questions for Andy.
I'll accept heckling. A little bit of information about myself. First, I've been with the company for about a year with Nagios. I like flashy things. So we're going to run over, just a heads up, this is going to cover mostly XI. Visualizations you'll find in XI. There's a couple of goodies at the end, stuff we're working on. There will be some, so it'll be a high-level overview. I'll also be talking about a little bit of the philosophy and psychology of data visualizations. Again, we're going to be using XI and some of the upcoming features that we've been working on in-house. So usually most people end up in a situation, they're running their monitoring product. You end up in a place where you have all these bits of information coming in. You're doing things with them, sending reports, running event handlers, firing off scripts, forwarding to a ticketing system. All that's fine and dandy. It's mostly automated. But a lot of times you run into a situation where you need to drill down the data more, or you need a very specific data set, whether it be for a requirement or whether it be for like maybe a specific purpose. There's a problem in the network and you can't identify it with the current things you have available. So just kind of like a little talk. Most things are best off left automated. If you don't need to go look at the visualizations for you to either understand what's going on or for them to be taken care of, there's no point into doing so. And so a lot of times you find visualizations are more flashy than useful. So there's kind of some points that you want to make sure that, like, if you are going to develop a visualization or if you're going to be using it, that you meet like certain criteria. So just kind of heads up on some of the automation details. Most visualizations are actually UI, especially in the monitoring realm. You find that a lot of them are integrated together. You find this with a lot of tables, with a lot of, not necessarily graphs, but mostly tables, status information, summary dashboards. They're usually meant to navigate the UI, identify things that are wrong, and then drill them down from there. A bit nervous, I apologize. And so, like, the purpose of a UI is to interact with the data, not necessarily draw conclusions from it. We run into a lot of situations where you have a lot of rudimentary data and very basic visualizations, but a lot of times they're just, they experience what's like the single value syndrome, or you run into a situation where you have one single metric, these hosts are up or these hosts are down. It doesn't tell you why. Or else they have too much information. You deal with information overload. You have a very, very large list of metrics for an object, but you don't know what metric is the one you want to drill down into. It's just a quote, good old quote from Wikipedia concerning the basis for a proper visualization. I'm going to go ahead and read it for you guys. The main goal of data visualizations is to communicate information clearly and effectively through graphical means. It doesn't mean that data visualizations need to look boring or be functional or extremely sophisticated to look beautiful. To convey these ideas effectively, both aesthetic form and functionality need to go hand in hand, providing insights into rather sparse and complex data sets by communicating its key aspects in a more intuitive way. Yet designers often fail to achieve a balance between form and function, creating gorgeous data visualizations which fail to serve their main purpose, to communicate information. That's from Vitaly Friedman. One of the teasers I'll have for you breaks most of those rules. And so I'll be showing you that at the end. It's a little thing I'm working on in WebGL. Does a decent job communicating information, but it's definitely more form over function. So it's just some key pieces of information about visualizations. It has to be communicative. If it's not, it's failing at its main goal. It should help reduce large data sets, whether they be sparse or rather dense and complex, to manageable sizes and simplicity. The information must be displayed in a more intuitive way. If it isn't displayed in a more intuitive way, why the heck are you looking at it? It might be good for management, but it's not good for the techs, who usually need to identify a problem and drill it down. Form and function should be inextricably linked. If they're not, then you probably should take a look at the visualization and see why you're using it. It should also be good, certain ones at least, for developing an understanding of a relationship between objects. That would be like hosts and services or different types of groups in Nagios. Visualizations need to meet a certain realm of efficiency. I like to think of it as offloading data. You have a primary visual cortex, and it's very, very important that we actually make use of that portion of your brain. If we're not, then you might as well just fall back to like your prefrontal lobe and just use that. Like if we can't offload some of the processing power to the primary visual cortex so that you can understand the data faster and more effectively, it's probably failed as a visualization. So in a nutshell, they're optimizations. Kind of consider it like you're dealing with an architecture has multi-cores, and you know, one of them will be your prefrontal cortex, another one is your primary visual cortex. We want to be able to make use of the things that the primary visual cortex are very, very good at, which is the identification of patterns, the ability to use shape, size, color in order to correlate between different data sets. If it's failing to do that, it's probably failing to be a visualization that's actually useful. Kind of some other points here. A lot of times, especially in the monitoring realm, we deal with the particular and the general all the time. And very, very rarely do we run into a way to actually combine those two into an understandable set. Very often, you end up in a situation where you have one specific problem on the network, and the only views you have are very, very general. So you end up navigating a very, very clunky UI in order to drill down what the problem is, when a more effective way to display that data would have helped you hunt down the problem faster. So we're going to come back down here. Excuse the School of Athens there. Why should we care? What's the point? What are the real world impacts of visualizations? Probably first and foremost is convert the raw data, the tens of thousands, if not hundreds of thousands of lines that you'll have in status dat into something usable. Clearly reveal the relationships in data that would otherwise be obfuscated by the size of the data set. And again, that returns back to the ability to identify the particular from this giant general set. And then additionally, these are more for management. You want to present that technical data in a way that they can pull up a dashboard and understand what's going on, and even maybe also identify what the problem is. We'll see with some of the visualizations in XI, specifically like BPI, that it is a very good tool, front-end tool for management to be able to use to identify when certain business services fail. They don't really care if server A out of server A, B, C, D, E, F, G is broken. They really care if that means that the web app is no longer working and they're going to get calls complaining about it. The other thing is visualizations tend to scale really well. Tables are really horrible when you start dealing with the size of data that large installations will have. You can use search functions, drill them down to specific objects, but a lot of times you want to be able to look at multiple metrics on a select number of objects or over the general set and identify a trend so you can identify an issue with the data set. There's a number of aesthetic qualities you can use when building a visualization. You have length and width, possibly depth if you're going to go in, if you're going to go with like a three-dimensional visualization. Color gradients. Everybody here is familiar with that in Nagios: red down, green up, etc. Relative position and distance. This is most obvious in like the network status map or the Hypermap, where you not only have a topological overview of what's going on, you also have the distance between objects in the Hypermap will tell you how many hops or like parent-child relationships between hosts. Much easier than drilling that down through a text-based interface. Movement, again, there's very, very little movement in most of the visualizations. Maybe that's something that's going to change as HTML5 catches on. Size and shape, of course. And there's some examples of that. This is just, everybody's seen this screen if you've used XI. This is the most rudimentary form of a data visualization. It is in gray area because it is very, very static. It's a very static table. It's considered a portion of the UI more than it is a visualization. But due to the color, yeah, there is some rudimentary elements that you'll find, and you'll find this in core as well. Moving along, you find this is another form of data visualizations. In XI, this helps you identify problems with the general, not the particular. This was the particular. And this is really hard to deal with when you start dealing with thousands of objects. So the general view is usually very nice, but again, it's not going to tell you specifically what's wrong. You're just going to know that there's a problem with a current set of objects. BBMap will drill this down even further, and you'll be able to correlate the general by choosing different groups, service and host groups, and then taking a look at the individual services. You can also, there's some search functionality as well. So that's just an example of that. BPI, this is a big one in XI. This is usually not used very much by the actual techs. This is a dashboard that management wants to see. It's what you do is you create groups of most often services, and then you set thresholds for them, whether they be a certain number of boxes down or a certain number of services that have reached a problem state. At that point, it'll actually then kick out like a warning notification or a critical notification to people that there is an issue. Most often you tie those to management, not the techs. The techs already know there's a problem. They've already received the notifications from the individual objects. But for management, it's a great feature for them to be able to very quickly have one dashboard that allows them to see whether or not the business process is going to be successful that day, or if there's going to be issues and they're going to be dealing with angry clientele. This is one everybody else has seen, whether you're a core user or a XI user. This is a good example of relative distance, color, and size. Very, very hard to read when you start to have a whole bunch of hosts and you don't properly set up your parent-child relationships, which is on our demo server. And yeah, there's a little bit more work that could be done there. Probably a cloud somewhere that would be the router would be the parent of all of these objects, because they're all online. You can actually see the firewall here. They should be sticking out around here. But this is useful, but not entirely useful, again, because it is completely general. You can't, like as this sits here, you can't really drill it down very well. It'll show you topology, but once your objects hit a certain number, it's no longer manageable. The Hypermap is something that we've worked on with XI to really kind of clean up the interface. You've probably seen it in, there's some real good lookalikes in core as well. It cleans it up a little bit. It actually gives you like metric rings, so you know the hops. It's more or less the same function, slightly better looking form. Replay is an extension of that API, or I'm sorry, of that visualization or component. And this actually lets you set a time frame, and then you can go back in time and watch the behavior of a network looking at the general topology, which is really, really useful for discovery purposes. You'll find with visualizations that maybe you're not looking for a specific problem. Maybe you're more interested in identifying a trend. And so sometimes when you build or use a visualization, you're not looking for a specific piece of information. You're looking for something that might be correlative or a trend across the objects that you're monitoring. Oh, the Google Map component died. Oh, that's there. Well, imagine a map of Minnesota up there with about 4 lines on it. 5 lines, 6, 7 objects, some green, 1 red. It's an example of, again, it's a general overview, but this time you've laid the topology on a map, so now you have geographical locations. Very, very, very useful for more management, again, than techs. Again, most of us techs are going to know when something's wrong. We'll receive the notification right away, or once it's past threshold levels. And we'll be dealing with it. The management may not be, but they need to know that Sioux Center is failing, or that that there's an issue in Duluth with a specific service. Google Map component will let you do that, as will NagVis, which we'll look at here in just a minute. We've all seen this. This is the most rudimentary form of performance data visualization that's available for the Nagios products. Real simple. It is static. You can't drill down. You can't click on that point and identify what the actual level of that metric was. If you want, you can go ahead and use like RD or something to do that, but you're not going to get it from. What the heck? Give me one sec. Sorry for this, guys and gals. Well, here it is. That's blank? That's blank? Well, give me a second. I'm going to make sure the rest of these slides are here. I could open up a backup. That's frustrating. All right, this is the only other one I can identify that's missing. And okay, the metrics component. Actually, I'm going to open up the backup copy of this. There either. All right, well, I'm missing 2 pictures on those slides. I did run out of battery power last night, so. All right, the metrics component. Open your mind's eye. This will show you, this will allow you to compare the metrics on multiple objects. It would give you, if you can imagine, a bunch of bars filled up to certain points. Depending on the level of the metric, you can pull up disk metrics, bandwidth metrics, RAM, like CPU usage, etc., and compare them between objects. Really, really useful when you have a homogeneous group of servers that are all running the same sets of applications, whether they be in a cluster or a large farm, and it'll help you identify if you're having issues with specific machines that are all performing the exact same action. The alert cloud, more flash than function. It does have some usefulness. These are actually animated, and if you've used XI, you might have actually seen this. They will. It's a cloud. The larger the object, the more alerts it's produced in whatever given time frame you're checking over. And again, the color will then describe the type of issues that you've been having. Decent for a Nocscreen. You can put it up, and if something starts generating a lot of alerts, you'll be able to identify it rather quickly. This is an extension of a system that shows you who are the top alert producers. This is the Heatmap in XI. Certain objects, like you'd choose an object, and then the services would be listed across the side here. The number of alerts that are generated over time, obviously the hotter the map, the more issues you have. The alert stream is probably the final natural extension of a alert-based visualization. You can actually see here we have multiple objects that we've pulled into this visualization. It's actually testing it based on a host group. And it'll show you who are the top alert producers. Over time, again, it does stack, so you actually can have more than one object. Graph Explorer is something that we introduced last year. It uses the HiCharts API. It offers a very, very clean interface. We find it as a very good replacement for the PMP static images. There's a handful of features. Here's like top alert producers. This would be the last place you'd actually find that information. Again, it's stacked. This is a little bit more clean than like this or this. Still useful. Moving through the Graph Explorer, you'll find pie charts and other bar graphs that deal with specific service health, specific host healths. These are very, very useful for management when they want to help identify certain problems on the network, or they might be looking at giving promotions or raises, and they want to see how many times you've had problems and how long those problems existed. The last portion of Graph Explorer, which I find is the good replacement for PMP static images, is this is the meat. This is the Graph Explorer. There's a handful of ways that you can deal with this. You can pull up a single metric. Now, you can actually mouse over this because it's all done in JavaScript, and it pulls the RRD in JSON into memory on the client side, and you can actually then see exactly what value that peak was and exactly what time. This is a time stack graph, so this is multiple days stacked on top of one another. You can actually see here for the last 3 days for this host. You can do the same thing with services, and as we'll see later on, there is something we're currently baking that has the ability to stack multiple metrics from multiple hosts and deal with the normalization of the y-axis. NagVis, this is something that the core users and the XI users have access at. We will be updating the version of NagVis and XI. I think we're on like 1.5 and change, and it's currently up to like 1.7. If you haven't used NagVis, it's definitely worth looking at, especially if you're looking at laying status information on top of images. Like a lot of people use them for racks, ports. This way, your cable laying in turn does not plug the cable into the wrong port, or if he does, you can actually tell. Moving on through NagVis, there's some more options. Like here's this is a map set up by one of the core users in Russia, and this shows housing development and the connections between them. And so you can do the same thing with your different offices, or if you have a large institution, either you're dealing with a very large campus or multiple campuses. It's a good way to see, identify where routers are failing in the topology, so you know that Jim from building C is going to be calling you instead of Andy from building F. Last slide here on NagVis. Works really well when laying down flowcharts for how your network works. Each one of these that you've seen on all these screens, if you're not familiar with NagVis, represents the status of a machine. You literally import an image, and then you can use its graphical interface to set up each one of these like mouse overs, and like you can see the mouse over here and a mouse over there. Shows you all the status information. Those you just place right on the image, right in the UI, whether or not you're using Core or XI. I highly suggest if you are looking for a better way to represent your network topology, or to represent like multiple campuses or your racks in a large farm, that you take a look at NagVis. It does some things better than just about everything else out there. It's been around. It does have multiple backends. NDOMI is one. I don't think it's supported for the auto map feature anymore that uses NDO. There is MK as well that it supports, and that's full featured. Ops Center is one of two like what we call like Nocscreens that you'd have in XI. This is a little bit cleaner, holds more true to our base XI interface. Gives you some of the most important warnings for hosts up top, and then sorted by duration below. Now you can, these will enter the Nocscreen until they're acknowledged. Once they're acknowledged, they'll disappear on the Ops Center and the Nocscreen. Nocscreen is something that we put a lot of work into customizing. This is it's used by a number of our clients in their large offices to deal with failures on machines. Like this Nocscreen is set up specifically only to post actual criticals. Warnings won't actually hit this screen. That was it was a custom job that we did for somebody as well. So in development, some things that we're kind of cooking. One, a multiple data source stacked graphs. This uses the HiCharts API. Jake, one of our PHP developers, has been working on this. One of the biggest problems when dealing with stacking different types of metrics is the normalization of Y. You either just force them all to hold to the same value, and then you get very, very disparate graphs. You know, like if you're measuring ping on a slow server against number of users on that server, and that server never sees more than 4 users, you will not be able to actually see any correlative information between the two. So what we've been working on is the ability to then sculpt the y-axis. Basically, this metric, it's ping, you know, and maybe we'll set it to a ratio of 1. This metric is users, we'll set it to a ratio of 10. And so that way you can actually like see the relationship. How many users were on this machine? How many outbound connections? What was the CPU usage? And how many forked Apache processes, et cetera. And being able to lay all that on top allows you to very quickly identify if the peaks match up, or if there's any relationship between the peaks. The other one that this is my personal project that I've been playing with, called GLMap. It uses WebGL, HTML5 canvas. There are a number of fun little things with it. I do want to warn you, it is not a real visualization. It is a UI, as we talked about in the beginning. It's mostly meant to see kind of a general overview of the network and then drill through objects in a fancy 3D way. It does provide real-time check information. They aren't interoperated yet. There's an AJAX loop that runs, updates them, and then once the AJAX loop is picked up the new status information, it will animate those checks going out. It uses the XML backend. Currently, I'm probably going to dump that and move to the JSON CGI because it removes a layer that I don't want to deal with, which is grabbing XML with database lookups. I'd rather get it from the JSON CGI. This is an example of the stack graphs component that will be coming probably in 2014. You'll notice that we have 3 different metrics here. We have a string check, a ping check, and another ping check. And this is something that Jake has been working really hard on. You guys can kind of just see what it does, and you can imagine it, like if you can start stacking multiple metrics of different types, control the normalization of Y, you'll actually be able to pull some very, very interesting information from that. This is a couple of screen caps. I'll play a little video. This is the toy I've been playing with. I have some ideas of creating an actual network status map with parent-child relationships. It is coded in WebGL. It is heavy. It takes, I don't know, 300 megs and a decent video, 300 megs of RAM and a decent video card. Before I rooted out the problems in some of the JavaScript that were hitting performance, it was at a gig. So actually, so there's you can see these little boxes here are just checks going out. They'll probably end up being a shader at some point instead of an actual mesh. Each one of these represent a host. The size of the host represents a service. I'll probably be chopping up the hosts into separate objects that represent separate meshes that represent each service on the object. And then here's just kind of a little teaser that it is pulling all the status information and all the object information, and it can even pull up the graph. There's no graph on this one because I think there's a timeout problem in MPCD. You guys probably understand that. This is something else that I've just been toying with. This is an example of a bad visualization. Like even if there was a way to normalize Y and there was all the proper text here, this is pulling in a whole bunch of RDs in JSON, graphing them in WebGL. It's a bad visualization. If you're looking at peaks, the last thing you want to do is use perspective when looking at peaks. An orthographic camera might be an option, but you can always change the position of that orthographic camera. It will lie to you. If you look at peaks from one angle and then from another, you will not gain the same understanding of information. I'm going to stop here for one moment. This is kind of an example of like what it looks like. It's a little bit choppy due to this screen grab. It runs just fine on hardware with a rather lightweight video card. It's been a toy. I used it to learn what's going on the back end of XI and of Core. This will probably become something bigger and better over time here. HTML5 is rather new. WebGL is 2 years old, give or take. So 3JS is still coming along. I think it's might be approaching maybe version 60 at this point. 3JS is a WebGL library, JavaScript library. You tend to use jQuery and 3JS in combination for this. So it's fun. Whether or not it's useful can be debated. Why are we back here? So building your own custom visualizations. Really, really important things to know. Learn the API. If you don't learn the API, you're not building a visualization, and probably learn more than one of them. There's probably, in most of my examples, you're going to want to be able to interface with RDs so that you can pull performance data, and you're going to want to be able to pull status data and object data. Whether or not all that's wrapped up in 2 or 3 APIs is your choice, but learn the APIs. Understand the requirements or goals. You can't build a visualization unless you know why the heck you're building it. I built the 3D visualization so that I could understand the back end. Whether or not it's useful has yet to be seen. I have more requirements to lay down for that. But if you don't know why you're building it, it's probably not going to go anywhere or be very useful. More metrics do not mean it's better. Usually it means it's worse. Very, very rarely do you run into a situation where you want to display the entire general set of data and force the user to drill down into the particular with another portion of the UI or another visualization. If it doesn't do one thing well, at least one thing, it doesn't do anything well, and it's probably not worth using. Don't add metrics when you go to build a visualization. Don't add metrics just because you can. There's 2 major types of visualizations you'll find. Those that are meant to root out a very specific problem, and there's been visualizations that have been sculpted specifically to help you find that type of problem. And the other type of visualizations you'll run into are those that are meant for discovery, so that there's a problem, you don't know where it is, you don't know what you want to access, so then you want a rather general data set, but it can't encompass all metrics. If it encompasses all metrics, you'll have data overload. You won't be able to figure out any relationships between the data. Flashy is not necessary, but it does help. It really does when dealing with management. So last bit of information here. Visualizations, they must assist in the understanding of data. You have to be able to make use of the fact that we are really, really interesting, creative animals. We have a very, very powerful visual cortex. We should be using that. Pattern recognition is much better in the visual cortex than it is in the prefrontal lobe. And so make sure that you're doing something to use that, and that falls to the graphical or aesthetic quality, size, shape, color. If you can use these to display a metric, replace text in a visualization, it's probably worth doing as long as it's clear what the colors or what the shapes or the sizes or the distances mean. That allows, again, for the visual cortex to pick up the processing overhead. If all else fails, maybe management will still like it, and they probably want it on their dashboard. That's about it. Questions?
So you mentioned a very specific group of visualizations that cannot be abstracted. So you mentioned a specific group of visualizations that can be described as really useless, but management will like it.
Mm-hmm.
Have you ever gotten confirmation that management likes it and it's useful?
Yes, there are a number of visualizations that are almost useless. I mean, most of them will have some use, whether or not they just be up or down. I mean, again, that's like the host group summaries or the host summaries in general. Like those are nearly useless. They're very, very general. They'll tell you, yes, you have 5 hosts that have a problem. Now, management usually doesn't care about those. The BPI is something that management does care about that's actually very useful. There are a handful of other types of visualizations out there that management really likes, like maybe a 3D rotating network map that they would really, really like, and maybe you build a spaceship, fly around, and shoot things with it, and then they have something to do all day in their office. There are many, many different uses for visualizations. The flashiest ones tend to be desired by people who want only the highest level of understanding of it. They don't want the nitty-gritty. They're just looking for an overview, and so you have less points of interest, and so it gets dressed up more. Does that answer your question?
Yeah, that's fantastic. So you're using a high chart, and it looks awesome. Are you using the RRDs from PNP as your backend?
Yeah. They pull there's a PHP script RD fetch that pulls the RD in with RD tool, and then, or I think it's RD dump, and then dumps it to a JSON array.
And are you happy with it?
Seems pretty good. Seems pretty good. I mean, there is probably the only thing you'd run into is you're only getting the specific set of data that you've asked for. So if you want to start drilling down through time, you might pull the RD again. Some RDs get very, very large. You don't necessarily, if you're only interested in 24 hours of a big RD, you don't necessarily want to convert it all to JSON and pull it all in.
I agree. Thanks.
Yeah.
I think we had another one over here.
More of a suggestion than a question. I was talking to someone earlier about maximum values, and we'd like to see some graphs that have, you say, instead of averages, or have the average but have the maximum value and the minimum value displayed on the graph as well as points, so that, you know, when I'm looking at user sessions for last month, I don't want the averaged out number because that's irrelevant. I want to know last month on that day what the maximum amount of.
And it's mostly possible with RDs. I mean, you run into the problem with RDs, though, the farther back in time it gets, like it is averaged back in over and over again. So, like, even if you do pull the max value from 7 months ago, it's not the true max value. And I don't really know of a good solution for that other than storing everything flat. And at that point, you run into massive, massive uses of disk space. So and the lookups get horrible. Like, RDs are kind of like, they're not the best solution, but they're the only one we got.
Any other comments or questions for Andy?
Not as much about RRDs, but I think if people are considering alternative to RRDs, NoSQL databases, something like Redis, might be good to get developers on to see if we can get a backend for data, because you can quickly access it and you can store the data and you can make dumps available going way back.
So you're talking about replacing RDs with like an SQL or Mongo or something?
Yeah.
Or?
I actually have a question specific to visualizations. I was interested to see if there are any good tools for visualizing large networks. I'm talking about something like 1,000 hosts or more, and I want to see what's going on the network.
Yeah, that's something I've been putting a lot of thought into. You really, when you're dealing with that number of objects, right now it seems like the only way that people, the only visualizations that people have built are very, very general, high-level number of objects. I'd like to see something that can actually represent each object individually as well. I'm open to suggestions on that because once the conference is over, I'm going to be going back and hitting JavaScript pretty hard. So. Huh?
It's a lot higher relationship.
Yeah. Any other questions?
Quick question here. Is NagVis part of XI?
It does actually ship as part of the interface. It's been version 1.5 for a while. I think we're I just finished making sure that it's going to work with the newest version. It no longer the newest version of NagVis no longer plugs into NDOMI for the backend for the auto map. It still works with NDOMI for the other portions of the features, but if you wish to use the auto map, you're going to have to move to Live Status or some other broker.
Any other questions for Andy? All right, does that wrap it up for you?
Yeah, we're wrapped up.
All right, excellent. Well, let's give Andy a big round of applause, please.